Ladies and gentlemen, good afternoon. I hope you enjoyed your lunch. Please take your seat in order to start. So I would like to welcome you to this session, Trustworthy CCAM. As you can understand, trust is a very essential and sensitive word. If you have followed other sessions, you have seen also this word repeating in other sessions, connectivity and trust-based solutions. So I think this is, I would say, an interesting session that we are going all of us to follow this afternoon. So as described also in the CCAM Strategic Research Innovation Agenda, one of the problem drives in the CCAM solutions are not sufficiently mature actually for a wider market app. One of the key elements to further deploy the CCAM-enabled solution, mobility solution, is to ensure secure operation of vehicles and mobility systems, and also to establish trust and acceptance amongst the end users. Extending the domain, the system domains beyond the vehicle through connectivity makes, of course, cybersecurity a fundamental building block for trusted digital interaction of road users with each other, the infrastructure and cloud-based solutions and services. Systems for CCAM needs to be fairly operational and secure in their entire operational design domain, because they are the so-called ODD, guaranteeing a safe and secure operation of vehicles, independent of course, the respective security level the element or system has within its ODD. As also presented in the CCAM Strategic Research Innovation Agenda, one of the specific objectives is to ensure secure and trustworthy interaction between users, conventional vehicles, and also infrastructure and services in order to achieve safer and more efficient transport flows, either for people or for goods. And of course, better use of infrastructure capacity. The operational objective, which contributes actually to this specific objective, is to enable trustworthy interaction between all traffic participants and CCAM by 2028. So it's not too far. So we are going to touch upon this now topic with an interesting panel, I think. And we have actually invited 3 EU-funded projects. And of course, I would like to welcome them and to thank them actually for their participation here today. So we have representatives from Connect project, from SELFY, and events. Of course, we are all eager to see how trust relationships have been developed, trust model has been defined, and based on which your consortia actually can establish trust for cooperatively executing safety critical functions. In this session, of course, I'm not alone. I have the pleasure to thank Ms. Oihana Otaegui, who actually is going to co-moderate this session and help me and support me during the Q&A session. And also, I would like to remind all speakers that you have approximately 15-20 minutes to finish your presentation, to give your presentation. And after these 3 presentations, Oihana actually will open the Q&A session for your question. And actually, you will have the opportunity to interact and ask your question to the speakers. So without spending more time, I would like now to give the floor to our first speaker, to Mr. Ioannis Kontiris, on behalf of Connect EU-funded project. So Mr. Kontiris is a senior researcher engineer at the European Research Center of Huawei, Germany, where he has been working on security, privacy, and trust technology research. And in the last 5 years, he has been focusing on the cooperative connected automated mobility. So, Mr. Conte, the floor is yours.
Thank you very much. Yeah, I will be presenting Connect, which is a project focusing solely on trust and trustworthiness in CCAM. It is a project that started exactly 1.5 years ago in 2022. So we are halfway there right now. We are a project of 17 partners. A lot of industry is there, OEMs also, and academia. And we are part of Cluster 5 of CCAM partnership, so looking at future technologies, especially for key enabling technologies. The objective of Connect is exactly to answer the question of trust. So if vehicles are exchanging messages, V2X messages, with each other, right now there is no way to assess the trustworthiness of the data inside these messages. Of course, yes, we have spent many years in securing the communication of V2X. This already creates a base for trust because we can trust the security of the communication. But it's not only that. We don't know about the trustworthiness of the information inside the messages. So if another vehicle is sending you some message, would you ever use it to take a safety critical decision? Would you ever use it for something more than giving a warning to the driver, even thinking of more advanced use cases of day 2 and day 3, where you actually put it as an input to take action, like emergency brake or something. Right now, no OEM would ever use this information from other vehicles because there's no way to understand if this information is reliable. So exactly, Connect wants to unlock these messages, enable receiving vehicles to quantify the trustworthiness of this message. Have a number. How much I can trust? I can trust it 80%, 90%. And compare this information to what is the required trust that you need for your specific use case. This is the main objective of Connect. We do that doing a dynamic trust assessment. That's a basic element of trust assessment. It has to be continuous. It has to be dynamic because the situation changes all the time. Security threats are coming anytime, so you cannot rely on the past. The second thing that is important in Connect is that we leverage specific security mechanisms like attestation mechanisms to enable the establishment of trust relationships. So we're using trusted execution environments inside the vehicle. We're using trusted computing and cryptographic mechanisms to generate evidence, to generate proof that other vehicles can use as a base for the trustworthiness assessment. And we also take into consideration not only vehicle to vehicle, but also vehicle to edge, specifically multi-access edge computing. So to have trust establishment also between vehicle and edge, because let's consider offloading of computations to edge and things like that. I have some slides later where also trust is important. So the main artifact produced by Connect is what we call it TAF, Trust Assessment Framework. Is a generic framework. It works for any property of trust that you can use. I heard in this morning from podium talking about truthfulness of information. There are many ways you can assess trust. You can assess it based on accuracy of the sensor data, on reliability, robustness, you name it. So the TAF framework is generic enough. It accepts the information you want to, as input, the information you want to assess the trustworthiness of, and also accepts evidence for the trustworthiness. This evidence can be produced by trust sources. The TE is one, but it can be anything. This behavior detection system can be another one. The PKI security of the communication can be also another one. So it's agnostic and generic, and verifies the evidence and turns this evidence to quantifiable trustworthiness of the data that you have. Important is that you will always have some uncertainty in the evidence that someone will give you about the trustworthiness of the data. So how do you deal with uncertainty? We don't know yet. We don't have tools, we don't have methodologies to deal with this uncertainty, or models, I should say, and calculate trustworthiness out of it. I mean, now we do it in TAF. We are using subjective logic, very advanced models and approaches to build the TAF. The second artifact is, like I said in the beginning, we use a specific way in Connect for trust sources, which is the kind of a trusted computing base that provides necessary capabilities for the runtime attestation of the vehicle use and sensor device characteristics. So you get guarantees that everything on the vehicle is running properly. It's not compromised. Everything is up to date, and everything is operating as they are supposed to. This computing base is generating verifiable security claims that can be shared with other vehicles for trustworthiness evidence, is what I have explained in the last slides already. This is happening in real time. Therefore, we can have this dynamic element of trustworthiness assessment. We have been developing some advanced cryptographic mechanisms because, of course, you have the privacy requirements again. As we have seen in PKI system for the communication of V2X, where we have suffered so much to provide anonymity protection, privacy protection, by having the pseudonyms, so that you cannot monitor, you cannot track vehicles on the street. Here is the same. If you send evidence for your trustworthiness to other people, to other vehicles, you don't want them to track or identify you from this evidence. So we keep this evidence also privacy protecting and enhancing. And that comes down to cryptography as always. The third aspect of artifacts and results is the digital twin. We utilize the digital twin to offload computationally intensive tasks that relate to the trustworthiness calculations that we're doing, but it doesn't have to be on the specific kind of calculation, it can be any calculation. So it goes to the general question, if the vehicle offloads some calculations on the edge, then you need these calculations to be executed in a trusted environment inside the twin, the digital twin, and then the result comes back to you with guarantees that it is well protected. We have been quite active in standardization activities, especially in 5GAA, where all the OEMs are meeting with MNOs to build standardized solutions for the communication of the vehicles. And there, I just came back from last week from 5GAA meeting. You can just hear about the question of trust everywhere, all the time from everyone. Because I think everyone realizes in the industry right now that if we don't answer the question of trust, we cannot commercialize V2X, right? So I think it is quite obvious. So we are directly have working items from, and we have a cooperation between Connect and 5GAA, and we are pushing directly the solutions there. Also, we have a lot of standardization activity in ISO. There are several ISO committees on intelligent transport, but also trustworthiness. There are a lot of ISO standardization activities trying to define trustworthiness, not in vehicle domain, but in AI domain, in everywhere. So trustworthiness is a horizontal concept, and it's so difficult to define. Also in ETSI, with especially ITS and misbehavior detection activities in ETSI, and trusted computing, TCG, and data spaces. Data spaces also a big area. Mobility data space is a big area that's growing very fast. And again, you need to have trusted data to share. So moving to impacts, moving to the future, let's say, impacts of the project. Okay, one, of course, is what we directly target and what I explained already quite well, I think, is to enable day 2 and beyond applications by unlocking the V2X messages, enable V2X messages to be utilized in CCAM applications. But what is not directly addressed by Connect, but I think the solutions that we're building can be directly used, is the AI, the trustworthiness AI. So I think the TAF that I just described in the beginning can be used to assess the trustworthiness of training data of AI algorithms. Let's stick to CCAM applications where you integrate AI already, and I think it's everywhere also in the roadmap of CCAM also. So if you use these artifacts to understand the trustworthiness of your training data, then you can only make a link from that to the trustworthiness of the output of the AI algorithm and have a good answer about how much trustworthy is the output that an AI is giving you. And right now, nobody can answer this this question. I think it's a big question of the next few years, and I think Connect is delivering some good base for constructing an answer to this question. Okay, and that I say that just not because it's something we do in Connect, but it's something we are extending already our research based on what we have done in Connect. Yeah, that's all from my side. Thanks a lot.
Thank you very much, Ioannis, for your nice presentation. If I may to say, indeed, AI actually is evolving too fast, so we need actually to understand if the information received is trustful or not. And also, what I pointed out is about that you're trying to quantify the trustworthiness of the messages, so of the different messages that you receive, and also that you actually implement a dynamic assessment, trust assessment. So this is really interesting points that I actually figure out from your presentation. So now actually we need to move on to the sister project, SELFY. So today, unfortunately, project coordinator Fanny Burley is not available to come in Brussels. So actually, her colleague Victor Jimenez will make the presentation on behalf. Victor Jimenez is working as an IT security researcher in Eurocat and is mainly focused on system and hardware security in the automotive and industrial sector. So the floor is yours.
So, hello everybody, thank you for joining this session, and thank you for the introduction, Georgios. So, we are here to speak about SELFY. In other conferences, we have already explained. So, SELFY is a project that goes about cybersecurity and trust and privacy also in the CCAM sector. And SELFY comes because it's a tool that it's providing this self-assessment, self-protection, and self-healing tools for this trust. As we know, trust is really important for this trustworthy and resilient CCAM. So, yeah. Okay. Overall about the project, that's an European project of 3 years of duration. We are now at the middle of the project. Here we have some figures, budget, and different partners, and it's being coordinated by Eurocat. But of course, there are many partners that they are providing technologies in terms of research centers, universities, industrial partners, one public authority, and one private association from different regions of Europe. And also we have some collaborations with Japan and Australia. This is more or less about the consortium of the project. And as I was commenting, the objectives are to provide these innovative and collaborative tools responding to threats, risks, and attacks in the domain of cybersecurity in the CCAM. SELFY at the end is a toolbox. As you see in this icon here, is a toolbox which is composed by 3 big group of tools. The first one is based in situational awareness and collaborative perception. The name itself defines what is it. So there are many tools that provides perception, and we are providing perception to other vehicles, to the infrastructure, and with these algorithms we can provide some resilience. These inputs go to the cooperative and resilience and healing system, the second tool, the CRHS. Okay, you will see here we have some tools like BSOC, some algorithms, audit box, different kind of tools that provide resilience to the system, and also provides self-healing ways to solve a problem. And the third big group of tools is the trust and data management system that provides trust not only for the system but also for the end user. Like you will see, we have some tools of anonymization, as it was commented by my colleague, anonymization of the B2X. We don't want that anybody tracks the users. We understand that the users don't want this. And also we anonymize the faces and license plates of the vehicles and so on. We will check it later. Okay, for the results presentation, we have prepared a short video, but first of all, in the first part of the project, we have been working on the system architecture, let's say. We have been gathering system requirements that they have been allocated to 21 tools that we are developing. Remember, we're at the middle of the project now, and they are being allocated to this system architecture. We have considered a huge list of standards with all the partners. At the end, we have pre-selected 42. We also had a debate of use cases to validate the SELFY solution. At the beginning, we had 47 use cases, and we selected 12. And we did this selection not only with internal debate in the SELFY consortium, but also we had some workshops with external stakeholders, OEMs, cities, traffic management centers, and they provided to us some priorities and requirements. At the end, we selected 3 big use cases, or 3 big macro use cases, let's say, that are distributed in these 3 big cases. The first one is resilient cooperative mechanisms for vulnerable road user safety. This scenario, we are going to be to validate it in real-world scenario. In one of the partners, IDIADA, will provide their track, so we will do some real-world validation in the track. And also some of the use cases, they are going to be validated in the city of Vienna. The second scenario is secure empowerment of backend system for traffic management system. Other kind of tools, they are going to be validated here. It's going to be a laboratory validation. And the third one is robustification of a platoon, classical one. And here we are providing some, it's more related to simulation, to some methods and to some tools that they are more related to simulation. So as I have commented, until now, we have developed partially these 21 tools. We are now at 40–60% of the first of the development of the tools. This is done in the first iteration of SELFY, but now we began the second iteration. And it is divided in these three big group of tools, okay? The situational awareness one, the cooperative resilience, and the trust and data management system. And the validation activities, they have started, mostly focused by the moment in simulation. And during the second iteration of SELFY, we will more focus in the laboratory and real-world validation. So now, next slide is going to be a video. I don't know if when I press the button, the video will start. I will try to have some trustworthy communication with the backend. So if at some moment I need pause, I will say pause and they thank you. So yeah, let's put the video. So remember, there are three big group of tools. So we are this is a toolbox with these functions that I have been explaining. And the first group of tools is situational awareness and cooperative perception. So here you will see some tools, maybe pause. It works? Perfect. Yeah? Trustworthy communication, it works. That's perfect. Okay, in this first set of videos, we are going to see some videos more related to data aggregation and fusion. And there are different kinds of tools. In this first tool, there is this tool that is fusing all the onboard perception of a vehicle with other perception that is collected by other vehicles, with the messages of CAM and CPM messages of the V2X. And they are fused all together in a map. You will see, maybe you can put play, thank you. So you see here the blue boxes, the green boxes, the orange boxes, and it's how the different perceptions, they are fused in one map. Okay, another tool is the situational awareness module. Maybe pause, thank you. This tool is, with these inputs that they are collected by perception, is able to detect anomalies. This tool makes the different kinds of anomalies. We can have anomalies because there is an anomaly on perception, or it can detect also situations like GNSS spoofing. And it's a really short video, please play. It's really short because we don't have time to illustrate all the tools, but you will see at some moment on this simulation done with Carla, you will see that there is an anomaly detection here on GNSS spoofing now, and before it was mismatch perception. Okay, it's really short video, sorry for that. Then we have also tools that they are vehicle-centered tool for situational awareness. In this video, you see how the camera is detecting vehicles, in that case, 360 surrounding view with all the vehicles detected on both sides. Also on the traffic monitoring tool and ETS station, this is the perception mode on the right side unit. Here you see a vehicle, a pedestrian. These objects have been detected by the tools. Here you have a map and you see some warning situations. And then pause, please. And then with other tools also, we are collecting what we see from the cameras and fusing with the sensors, also on the right side unit. And as you will see, we are making the same like in the vehicle, and we will fuse all the data and detect coherent or incoherencies. Okay? Play, please. And it's similar to the previous video that we saw, in which we are, what you see here on the right-hand zone is the fusing of the sensors and the perception of the cameras on this video on the right. Okay, other tools that we have, threat evaluation tool. This tool, what it makes, it detects these inconsistencies in the right side unit. It's not a visual tool, so we pass, maybe pause. Okay, and that's related to the first situational awareness and collaborative perception tools. Now we jump into the second big group of tools, which is cooperative resilience and self-healing tools. Here we're going to see a couple of tools, one more focused on simulation and methodologies, and a second one, you will see the setup that we are preparing for one of the other tools. So please pause, I play. Okay, so, yeah, okay. The first tool is interaction-based verification and validation tool. This tool takes some UML models, and it takes from the models to runtime verification, and it checks different possibilities, and with the traces that they are being collected, it detects if the situation is expected or not. Okay? You see here all the iterations that it makes this tool. It's a simulation tool, and at the end it detects if this is a good movement or not. Okay? And it can detect problems also. The second video is the safety operational tool. The safety operational tool is a tool I can begin to explain. Here you see the simulation, how we are preparing the setup for this tool. What it does, this tool, is in case that there is some problem, GNSS spoofing, there is some attack or whatever, it makes a fail-safe trajectory to the vehicle. Okay? And this is all the setup that we are preparing also on Carla. With some vehicles, you see here the LiDARs, all the data that is perceived by the vehicle, and so on. And then the third, please pause. The third big group of tools is the trust and data management system. And yeah, play, please. And here you will see a couple of tools also. We have the V2X privacy tool. This tool tries that they don't track us in our movements with V2X. So it provides different pseudonyms to a vehicle that is passing through a right side unit. Okay. You don't see really much on the video, but it's not a graphical tool, but it is what it does. The right side trust tool, this is on the other side, what it does, we cannot allow that a vehicle is changing their ID really frequently. It will be a civil attack. So it detects also these situations, this tool here. And the third tool is really graphical, is data anonymization. You will see this tool that what it makes is anonymization of the faces and plates of the vehicles in order to reach user acceptance. Okay, so we want the functionality, but we don't want to track people, or we don't want the data of the people, and so on. Okay, so that was the video. It's a short video because we are at the middle of the project, but we wanted to show some tools to you that normally in a video it's easier to understand the concepts. Okay. So other results, for sure, we have done a lot of cross-project cooperation. We have been working with Connect, with FAME, Frontier, Podium, many projects. We are trying to do many clustering activities here. We have 6 scientific publications so far, 5 publications which have recently been accepted, 4 publications under review, and 8 which are in preparation and plan. And we have been in many congresses during these 18 months, okay? As you can see here, some examples. And we will be also in other congresses in the future. Okay, so going to the impact. SELFY strongly contributes to the safe, resilient transport and smart mobility services for passengers and goods. And, okay, there are some evident impacts, like the SELFY tools will contribute to, okay, reduce accidents, for sure. If we increase the cybersecurity in the CCAM, we are going to increase the safety. So that's for sure clear for all of us. Increase trust. We understand that increasing the trust, we are going to increase also the adoption of the whole society in these technologies. And for sure, as many other technologies in the CCAM, we are going to reduce traffic jam, pollution, disruptions in the mobility ecosystem, and increase efficiency of the mobility management as well. Okay? And for sure, foster European leadership and creation of new jobs. Okay, another impact, as you can imagine, is validated safety and security, improved robustness and resilience in the CCAM technologies. We have a set of KPIs. I don't want to list all the KPIs here, but you can imagine. Some KPIs for us are increased robustness, identification of more vulnerable vehicles, reduce the detection times, increase the mitigation rates, capability to solve new kind of attacks. There are some kind of KPIs that we have. Also, we are experimenting with post-quantum cryptography in the CCAM sector to understand if it's feasible. We understand that it has some delays. So we are analyzing how it could be applied also. What else? Secure and trustworthy interaction between road users, CCAM and conventional vehicles. Okay, we have many tools of the TDMS tool, the third tool that I was showing. We have tools like secure software over the air, remote attestation service. There are some tools that they are providing this trust on the system. Also, roadside trust tool, the one that I was explaining, that we are avoiding the tracking of the users on V2X, and the data anonymization tool, the one that was anonymizing the faces of the people and so on. So we are providing this trust in two senses, not only for security, but also for end-user acceptance. Yeah, and related to this, seamless, affordable, and user-oriented CCAM-based mobility, yeah, I was commenting. On one side, we have this kind of tools that they are providing this end-user acceptance, and also we have a task in SELFY that is promoting, or we are trying to get some feedback of the users to understand the acceptance of these technologies. Specifically, we are trying to focus on some groups that we consider they are more vulnerable, like for instance, elderly people, children, or people with disabilities, and so on, to understand how can affect these technologies to improve their life. And also, as we are a cybersecurity project, to put the focus on cybersecurity and privacy and understand how this project can, what is important for them to understand, or what are their actual problems, current problems, to try to track this on the project. Okay, also better coordination of research and investigation and large-scale testing in activities. As I was commenting, we put in contact with Arcade and FAME projects just to understand and homogenize standards, the use cases, that they give us some feedback about the requirements of SELFY before to begin to design. This is some activity that we were doing. We were providing this, sharing this knowledge and solutions with EARPA and CCAM forums also. And yeah, we selected from the 242 standards, we selected 42. And in the second iteration of SELFY, we want also to be engaging or be engaged in different working groups of standards, because we think that maybe we can provide some input to improve these standards. Maybe there are some gaps and so on. So we want to collaborate in this direction as well. And lastly, but not less important, is that we are also, our goal is provide a data set, and this data set is a multi-agent situational awareness database. This data set, I think it has been already published in Zenodo, or partially, because we are at the middle of the project, but at the end of the project, all this data that is collected is going to be uploaded in public for all the CCAM projects. Okay, then maybe I am being too long, but also we want to foster this European leadership in CCAM services and ensuring long-term growth and jobs, okay? Yeah, and I don't want to repeat more or less these things, they have been repeated. So this is the last impact, let's say. So thank you for being here, and if you have later some questions, you can reach me. Thank you very much.
Thank you very much for presenting SELFY. I find one interesting use case that you have about robustness of a platoon. Maybe later on someone from the audience may ask a question on that. Also, I noted down the 3 big groups of tools that you have structured in the project. And also maybe later on in the opportunity of a question, maybe you can elaborate a bit more about the real-world pilot site that you plan to implement. And also that you are looking not only from the security point of view, but also from the end-user point of view and end-user acceptance, which is really, really important for this topic. So now we go to the next project. Events, of course, trust we need not only in normal traffic conditions, but also in extreme weather conditions. So we have invited events project, and representative from events today with us is Vasilis Roungas. He's a senior researcher and project manager at iSense Group of the Institute of Communication and Computer System of the National Technical University of Athens. So, Vasilis, the floor is yours.
Thank you, Georgios, for the introduction. Thank you for having me. Let me see the controls. Okay. Yes, so the title of events, the full title is Reliable in-Vehicle Perception and Decision-Making in Complex Environmental Conditions. Let me start with the... Yes, the big picture of the project. We are also more or less like the previous 2 projects halfway there. We are just running on month 18. Our total budget is 7 million, 5.5 funded from the EU. We are a consortium of 12 partners in total, 2 of which have 2 entities. That would be Hitachi from France and UK, and Aptiv from Germany and France. And I believe we cover more or less both the south and north of Europe. Yeah, so regarding the objectives, we have 6 mainly, and the way that we want to be able to validate them and track them. So one of the most important parts that we do, we want to design and implement onboard perception algorithms, and especially be able to, based on them, to overcome current ODD limitations in different environmental conditions. And for that, we have 7 prototype vehicles from the various partners that I will also link to the next slides, also with the use cases and the experiments. So that would be the perception layer. Another layer is, of course, the decision-making and the motion planning that the perception leads to. And we intend to, of course, be able to track this through specific metrics. The third objective is develop a solution that's a big part of the project about perception, assistance, and self-assessment. That's also linked with, I would say, the title of this session about trustworthiness. The fourth is to be able to integrate, test, and demonstrate the perception and the decision-making algorithms on the prototype vehicles, of course. And as I will show in the next slides, we have various experiments that are end-to-end, meaning that they cover both the different parts of the perception and different parts of the decision-making and motion planning. And of course, moving from the design and the implementation and the demonstration, we also want to assess different kind of parts of the events project. An example of which is the several sensor suites and the cost effectiveness. I will get back to that towards the end of the presentation regarding the impact. And of course, very important, besides from the technical part, very important to be able to communicate and disseminate our work, our results, and cooperate with other projects and with international stakeholders. So, moving from the big picture to a bit smaller one, these are the three, on the left side are the three use cases that create the premise for the project. So first one is the interaction with vehicles and vulnerable road users in complex urban environments. Second one is non-standard and unstructured road conditions. And the last one, weather-related, is about low visibility and adverse weather. So these have created the umbrella based on which we have defined the 8 experiments that you can see on the right. So to explain them a bit more so you can understand the image that these 8 experiments kind of draw. The first experiment, which is very focused on the interaction with VR use in complex urban environment. This has a test site in the Netherlands, in the city of Delft. Second one, which is re-establish platoon formation after splitting due to roundabout. Also what in the previous presentation about robustness of platoon, this is kind of related. This is a hybrid experiment, meaning it's both simulation and with a real vehicle, with a demo car. And it's a hybrid setup in the sense that the demo car gets feedback from the simulation. This will take, as a physical demo car, it will take place in Spain, in Bilbao, and the simulation will be both built in Spain and Greece. Third is about V2X communication, is self-assessment and reliability of perception data with complementary V2X data in complex urban environment. It also includes a real demo car taking place in Ulm, in Germany. Fourth and the fifth experiment is a big collaboration between different partners. So decision-making for motion planning in different conditions, so when faced with roadworks and unmarked lanes, but also when entering a jumped highway. And this would have 3 different test sites, so it would be France, south of France, it would be north of Italy, and Spain. Then moving to experiment 6, which is a small object detection at a far range in adverse weather condition. I will also show some preliminary results from this particular experiment, where we have built a new data set with different objects and how to track them. Moving to experiment 7. Experiment 6 will take place in Germany. Experiment 7 is about localization and perception self-assessment for advanced cruise control and other vehicle behavior prediction. And this is, of course, under adverse weather conditions or adverse road conditions. The demo car from here is located in the UK, so the experiment there will take place in UK. And moving to the last one, which is driving on secondary roads under adverse weather conditions. Again, like the first one, will take place in the Netherlands, in Delft. So, based on these experiments, which were defined based on the use cases, as a consortium, we have defined a master architecture having 5 main components. On the left, we have mainly the sensors and the map data, and of course the V2X communication. This is sort of an input which feeds to the perception, and the perception has localization, has object tracking, and then the perception feeds both to the motion planning, to the decision making, and to self-assessment, and self-assessment of object detection, of object tracking, etc. And eventually, the motion planning feeds to the control of the vehicle. So this is a master architecture defined for all experiments. Of course, some experiments that are more are smaller in terms of content and context will have parts of it, but there are several experiments that will utilize the totality of the architecture. So from a more generic image that I have so far presented, moving towards actual results, despite being already just on the month 18. Here on the left, a work we've been doing for quite some time now on data generation from simulation. On the left, I don't know whether it's very visible, but we have an image that is used as an input, which is an image of a road under a normal weather, and then using different machine learning algorithms, we can create different effects, different weathers, fog, snow, rain, etc. Of course, artificially. That's a big part that we've been working, and a second part is being able to automatically, using machine learning, to annotate videos. Videos, of course, being sliced into images and then being able to be annotated. So a big part of what we're working is that on simulation-generated data. And as I said earlier, part of one experiment is the small object detection, and based on the work done on this experiment, there's already been a data set created for different objects, and the setup of the experiment is shown on the right up image. And just a couple of images of different objects. There are many objects, 47, from 1 centimeter up to 3 meters. And be able to track these objects and determine whether there are overdrivable objects, or it's objects you need to avoid, or even brake and have a full stop. So that's a very, very interesting data set created. And moving from there to something that is very related also with the previous project that was presented, and I believe with also the session as a whole, and it's about collective perception messages. And about, of course, perhaps the greatest challenge on that is the trust, because it's not just perception messages, it's collective, so in the sense that I am the ego vehicle and I see something, but I also receive information from other vehicles or from other road users. In this specific case that we're working, it's other vehicles. And what is the extent to which I trust this information to be able to implement it inside what I consider that I see. So we worked, and specifically our developers have worked a lot on be able to create filters based on the Bayesian interference to create different trust map, let's call it. So if I be able to show on the right image, the gray image, we have the average, the gray to be considered a cell that we have 50% certainty that we have the correct information, that it's either occupied or not occupied, but we are 50% certain. And the more information we receive, then this starts to become gray. And the less information we have about it, then it becomes white. So the darker it is, it's the more certain we are that it's that the information we had about it can be trusted. It's trustworthy. And different examples on the left. So the completely left image is what the ego vehicle sees, what, for example, we see, and then we have the different views from the different vehicles, and then how be able to merge it and create a grid-based map that we can assign different trust levels. That's part of our work on the collective perception messages. And moving towards the mid and long-term expected impacts of the project, I have quite a long list. I will go quite fast through it. I said earlier about being able to not just have a general research on perception and motion planning, but be able also to talk about sensors, and can we have cost-efficient sensors, not just very, very expensive LiDARs, but can we have, for example, very cheap radars? So can we assess that? Of course, then moving to the more parts about perception and motion planning, be able to have prediction about advanced environment and traffic. And we try to measure this through the detection of, by improving the detection of VRUs. Then some parts about be able to improve the understanding of the ego vehicle, the connected and autonomous vehicle in the real world environment, and be more safe. We cooperate, of course, with Tier 1. Partners of us are Tier 1 that are very interested on that. We also are very interested in standardization, and our aim is to work with working groups. And to the more long-term expected impact, we want to, of course, validate the safety and security and improve the robustness of the technologies. A metric to do that is to be able to decrease by at least 10% the critical cases where calves are involved. Of course, we need for users, and especially vulnerable road users, to trust the system, so to have a secure and trustworthy interaction. So we need to have a high detection rate of VRUs, probably most important, but also of other objects, and limiting the false detections and the non-detections. And trustworthiness, it can be technical, but also it can be a social problem, so we need to have a high public acceptance rate. No matter how good the technology, people need to accept it. We also want to coordinate. We are already cooperating with a sister project, which is RoadView, and to some extent also with Project High Drive. And yeah, as with every project in this area. We want to create more high-skilled jobs. We want to contribute towards that. And that's more or less the impact that we expect to have short-term, mid-term, and long-term. And thank you very much for your attention.
Thank you very much. Thank you very much, Vasily, for your presentation. It will be very interesting, actually, to see afterwards, I mean, at the end of the project, how your perception algorithms will work, especially in extreme weather conditions. And it's nice also to see the color-based tool that you have developed in order to see that the more dark is the more safe. So the perception is a bit different now about the color dark. Okay, so then this is the end of the presentations. I would like to thank again all the speakers. All the projects are halfway, so I mean, I think we have a lot now to see, especially in the second period. But you have seen that the projects already presented some first results. So now we open the Q&A session. So we open the question and answer session. So please feel free to ask your questions to the speakers. For this session, I would like to thank Oihana Otaegui, Director of Transport and Security Division at Vicomtech, Spain, also representative of the CICAM Association, who is going to support me in the moderation of the session and also to help me on the question and answer. So, Oihana, the floor is yours now.
Okay, so thank you very much, Georgios. And before giving you the floor to ask all the questions that you have, I would like just to make a comment as CICAM Partnership co-leader of the Cluster 5, which is really these key enabling technologies, and it's the cluster where all these three projects are somehow framed. So I'm very glad to see that all three projects are somehow targeting what we have as main objectives in the cluster, so ensure that what for the past were somehow not so used technologies in CICAM, that they are taking into account these that are the AI, the data management, the cybersecurity, so that are somehow addressed by the project, that they are generating some tools that are also valid for other projects. So we heard yesterday, we have heard this morning, a lot on all the projects having this requirement on security, securing the communication, ensuring the trustworthiness of the data that we are somehow transferring and relying on. So I'm very glad to see that we already have some outcomes, and that at the end of the project we will have more that can and need to be integrated in the ongoing project and will serve as a basis for the next one, because this is something that all the projects should take as a requirement. So now I would like to give you the floor to ask the questions that you may have. So is there any questions? Yes.
Ivo Gray from Polis. In your project, what is the relation to the road authorities and the road authorities, the owners of the networks the vehicles are using? Is that something for later in higher TRLs, or are you working with these entities as a principal stakeholder?
Can you hear me well? Oh, okay. I think now you can hear me well. Okay. Yes. Okay, third attempt. Thank you for waiting. Yeah, I mean, in SELFY, we are considering from the beginning. We had some workshops with in that case, with the city of Vienna, which is a partner of SELFY, also with the city of Bordeaux. We were commenting the different use cases. They were explaining to us also their needs, their priorities, other kind of tools that we are not covering because we cannot cover everything in that kind of projects. But they were assessing our use cases and also the system requirements. And yeah, we took this feedback from the beginning, not only with the road authorities and the city traffic management centers and so on, but also with the OEMs and suppliers, service providers, association of users. So we took all this into account. Yeah, at the end, we have this final, one of the validations and the reward validation that we want to do it in the city of Vienna. And let's see how it works. Thank you.
Any other questions? Here around.
Yes, hello, good afternoon. My name is Sven Janssen. I'm from TNO, the Netherlands. I have a question about trust. Of course, it's something you need to exchange with others to know the trust of the information. So the question is, how do you quantify trust and through which protocols do you exchange that information? Which standards exist and are they sufficient to exchange that information?
I think that goes to connect more. There are currently no standards. This is the first thing. We are going there because we have several standardization bodies that we target, but for now there's no standards. So the information you need to exchange is kind of proof, or we call it claims, trustworthiness claims, which you can, on the other side, you can use to verify the trustworthiness. So for example, in Connect, we use some security proofs that the execution it has been done properly. The execution of the code has been done properly. But this is just taking the security aspect. You don't have to take the security aspect. You can create any other claims, for example, in misbehavior detection. Maybe that's easier for people to understand because more or less we have seen misbehavior detection systems in standardization activities. You try to understand if another vehicle is misbehaving, and you create these misbehavior reports. This can also be kind of input to the trustworthiness assessment. This morning I heard about the redundancy of information. So if there are other sensors contradicting evidence about what you see, that is also something else. Or the accuracy of GPS sensors. There are a lot of standards there and a lot of metrics how to understand the accuracy of sensors. Another source of information can be certification also. That is also easy to grasp because we use them right now. So if you use some kind of certification for your sensors or for your vehicle components, then this can also be input. So all this information have to somehow be turned into some claims, and you can verify it. So certification, you can verify. So this is this part for the information, but for how to turn this into a quantifiable number, like a number for trustworthiness, this is where Connect is applying this trust assessment framework that I described but basically we are applying mathematical models based on subjective logic, which are models that are specifically constructed for dealing with uncertainty, and try to combine different sources. I mean, they're also built to model trust relationships, because in a distributed environment of V2X, you have multiple relationships between multiple sources of trust. So these models are perfectly suited for this context, and we are applying them for coming up with this number that I said. Mm-hmm.
Okay, thank you. Yeah, I'm assuming then that those models to, let's say, to calculate the trust also needs to be standardized, because you need to get this information exchanged that from different parties.
Yeah. This is our right now. So this is exactly the activity we're just starting now in April in 5GAA, where we try to standardize exactly this part. But like we said, we need a couple of more years, 1 or 2 years to get there. But yes, exactly, you're absolutely right.
Okay, thank you.
Yeah, thank you.
Yes, hopefully for the end of the project we can have more standards, or at least having this. Any other questions?
Hello, I'm David Storer, R&I Director at Claypan, also leader of CCAM Cluster 2 on vehicle technologies. Now, I'm going to ask a question that I think many people have asked in the past, but I've not heard a very satisfactory answer yet. So we talk about trustworthy CCAM, but then we also talk about software-defined vehicles and over-the-wire software updates, which could presumably also be on the decision-making software. So my question is, how can we guarantee trustworthiness if we can update the software instantaneously?
Can you repeat the last part? How can we guarantee trustworthiness?
If we can update the decision-making software, I said instantaneously, but quickly, remotely, or will that be in some way protected?
But the very quick answer is that we cannot guarantee, I would say, 100%. It's always about building trust, like validating a system again and again and again. Yeah, I believe through... Yeah, I believe it should follow the road that you validate a simulation. You start building trust slowly until you reach a point that you say that I trust it enough. But I don't think there is a guarantee. No, you want to add something, Yanis?
Yeah, I think this is a good opportunity, and thank you for the question, to point out the dynamic aspect of trust. So trust it has to be continuously evaluated. It's not something that you evaluate once and you're done. So I think I tried to point it out also in my presentation. It has to be a continuous evaluation. So if you have the updates that you talked about, you have new software, but it's not only that, it's changing. I mean, a lot of things are changing, a very dynamic environment. So you have to do the evaluation at the moment that you need to make the decision. I don't know if that comes closer to your... Okay, then let me try again. The other part of my answer would be that like in Connect, we have these guarantees that the software is being executed properly, right? So even if you update the software, if you download a new version or whatever, so that will be again evaluated, and the attestation of the software will be again generated and being used as a proof in the next time you need to do the assessment. Okay, so you can if you want the guarantees, you have to use exactly this software attestation methods that prove to you that the software is the integrity of the software, the integrity of the code, and all the secure environment where it is being executed is kind of proof that you can use to have the guarantees that you need.
Related to your answer on that one, what would be the requirements for the actual in-vehicle architectures, ECUs, and so on for running what you are saying? Because it's going to play a key role if we are deploying or we are going into the software-defined vehicles architectures.
Yeah, you need these components in addition that are having this trusted computing base. So you need some extra elements for trusted computing to be inside the vehicle so that they are providing all these guarantees.
Any other? Sorry.
Hello, Pierre Chewan from Betty AV operator for rural areas. We are talking of Trustworthy, and lately we saw that the AI Act has been approved and released. And in the AI Act, Trustworthy of AI is one of the major points. How you manage trustworthy of the model, changing the model, trustworthy of the data, how you manage the trustworthy of the bias, and be sure that the model, when you put in big data, you don't have bias generated. So how do you combine this with what you are doing, noting that what you are doing is, regarding the AI Act, is a high-risk category?
Maybe I answer first, and I don't know if the others have also something to add, but because I had a slide on it, for me, this is the big question, and I don't have answer. I think nobody has answer to this right now. You can use the tools and the technology we're building in Connect to assess the trustworthiness of the training data. Because the TAF is for understanding the trustworthiness of your data, right? So you can also apply it for the data that you use for training. The question is, if you can quantify the trustworthiness of your training data, how do you transfer this to the trustworthiness of the AI model? This is the question. Well, I don't have the answer, but I think it is the next research project that we need to have. Yeah. I don't know if someone else. Okay.
Nothing to add.
Okay.
Just as we were talking about data, and two of the projects have shown that they are generating data sets or data. I have a question for both of you. The first one is for Bill, because you were telling that you are using also AI for generating data in order to generate some kind of bad weather conditions, so using this synthetic approach to enhance your data. So here, two things. So which are the challenges and the risk of using this, and have you some kind of measure on how different it is for our sensors having this kind of synthetic data versus the reality? And finally, you are only using this with a camera, or you are also generating?
No, it's multiple sensors.
Okay.
Okay, two parts. First, the challenges, right? The one is the obvious, that we are talking about high-quality images and hundreds of thousands or even millions, so we are talking about computational challenge. You need expensive machines that cost to obtain, that cost to operate. That's the first challenge. The second challenge, and we ran into this since we started, it's about untrustworthy results. That are actually the good part of these results that we got, that they are pretty obvious that they were untrustworthy, so it wasn't even a debate. But you need to spend a lot of time to correcting the simulation, correcting the algorithms to start obtaining results that you can even start questioning whether you can use it, because up to a point it's out of a question, you cannot use them. So we got a lot, so that was a challenge to start building these tools to be able to produce results that we can later use. I believe these were the two major challenges. And the second part of the question?
The risk of using this data for training your perception system.
Yeah, compared to real world. Well, first of all, it's certainly not replacing real world data. With simulation, what we want is to augment, is to enhance our data sets to be able to get data sets for corner cases, for rare cases, for very dangerous cases that we cannot put, especially other humans, in a car with heavy rain or heavy snow to recreate and get data. So a big part is to be able to obtain data that it's either very difficult, very dangerous, or even impossible in very, very rare occasions to get from real world.
Thank you. Other questions?
Hi everyone, I'm Franceschini Diego from Autostrade per l'Italia. I have a question that actually is connected with the previous question of the colleague of Polis. So, is it clear that road operator is an important stakeholder who can give you use cases and requirements, but we can give you also data, events, E2V messages, for example, regarding roadworks, weather condition, traffic jam, and so on. Has this type of collaborative perception taken into account in this framework? And a second question is, which is the trustworthiness of message and data that comes directly from the road operator? Thank you.
Okay. So, if we are considering this kind of data for the road operator, and if you are asking to SELFY project, at the moment we are not considering, unless it comes from the B2X channel, we are not yet considering. For sure, it can be considered all the supplementary data that can be provided by, in that case, by road operators, like traffic jams, whatever, and it could be mixed and fused. And so many cities, they are playing with that. They already told us. But as commented before, in the project we cannot do everything, but I think it's a nice question, it's a nice topic, and maybe as a next evolution it could be considered. But these projects, at the end, you need to make all the design or the validation and so on. You cannot cover everything. But yeah, we are maybe on the next evolution of these projects, we can begin to match more data, fuse more data, and provide at the end more functionality to the system. This would be interesting.
Yeah, just to add, for example, we don't cooperate with any road authority, but I think part of your question is how you implement the trust, right? If you get it from a certain authority. I believe there is some, despite the scientific methods, there is some subjectivity on how two entities between them evaluate and how they quantify trust. But for example, in what I saw in my presentation about the network, that each grid gets a different value of how you trust the information that you received. And there is, of course, the subjectivity, but then there is let's say, an objective translation of this trust into a number. But in the end, if we trust the numbers, then we start building a level of certainty on the different authority or the different stakeholder that we have received the information. So of course, if we're talking about an authority, probably the trustness is higher than from a less reliable source. But I believe there is a part of subjectivity that is implemented in something like that.
Pietro Perlo from IFES, Italy. You mentioned security, which is indeed a very complex topic and evolving very fast. But I never heard in your presentations any exchange of keys and the time frame of this exchange. An example just to be understood. If you have an RSA key to 2048 digit by a supercomputer, it takes 350 million to break it. A quantum computer takes only a few hours. But anyway, if you put a time frame and you exchange keys, you are, let's say, reasonably secured in exchanging your data. But my message is, I never heard you talking about the exchange of keys and time frames in this exchange of data or whatever. Thank you.
Maybe I answer first on this one because I did mention the security of the communication channel in the beginning. Because yes, it is communication of the security of the communication channel is important, and I think we have done enough to provide some guarantees. Of course, quantum computing is coming, and we are all aware of the risks there. So, like I said in the beginning of my presentation, security of the communication channel is not enough to generate trust. That is clear, because there are many other security threats. But if you want to look at the communication channel alone, and we realize that there's still also not perfect security there, again, you reach the same conclusion. You cannot have perfect trust. And therefore, we come to the very basic element of trustworthiness assessment, which is uncertainty. You do have always, you cannot have 100% trustworthiness. You will never have. You will have, but you will have, that's what I said, quantifiable trust. How much is the trust? It's how much uncertainty you have also about what you have in front of you. So what you said is a realistic attack. I can write a whole book about possible attacks in a CCAM environment with communication channel, ECUs inside the vehicle. I mean, the threat vectors are infinite, yeah? And therefore, we have to deal with a lot of uncertainty, and we have to deal with a lot of dynamic elements that continuously change, and yeah, so I think they're all incorporated inside the element of uncertainty.
Okay, just for finalizing, because I think that we're just with the time over, I would like to make a very quick question for the three of you. So we've said that the outcomes that you are generating are very valuable for future projects and the projects ongoing. So how can you share, or how can you put at disposal of this architecture or the tooling or the data that you are generating for the projects? And which are the main issues that you see for deployment of the stakeholders to adopt what you are already doing in the project?
Okay, related to SELFY, we have detected some different possible exploitation figures or exploitation possibilities, let's say. One, they are the guidelines, the system requirements, all this part that it's providing guidelines for design such a system. And later, SELFY is composed by a set of tools which can be exploitable by separate and also as a whole. The tools, they are designed in a way that a customer, in that case a road operator, a city or whatever, they could choose that tool, that tool, that tool, and that tool. They are not obliged to use all the tools. And there are different exploitation plans as a SELFY as a whole and by tool. SELFY as a whole, we think that we would need more standards or more regulations, or to, I think all the stakeholders have to agree on how to, there are important topics that we have to agree. Like one topic that I normally say always is that the data sharing, now you know data belongs to the OEMs, and how we are going to manage that all the participants of the CCAM participate with the data in order to satisfy security and safety needs of the end users. And this would be a main topic that I think in the next, during the next years, months, it has to be discussed.
Okay, basically very quickly from my side, also the same. I would say the difficulty is that OEMs, of course, have a lot of proprietary information. On the other side, I think the key to move forward is standardization and common agreements on formats.
Yeah, I'm kind of covered. Yeah, trust, building trust, and I think what Jan said about being not something that it's for granted, or that it's once established and never again examined. So that's
okay. So thank you very much. So thank you all of you for being active, for being attentive. And I would like to ask a big applause for our 3 projects. So now I think that you can enjoy coffee or next session. I don't know what it is. So coffee, okay.